Hello and welcome to Pike Mathematics. We want to thank you for taking the time to watch this video and going to our website at pikemathematics.org. We're excited today to introduce you to our Iota Math Platform. For those interested in math and physics, we think the Iota Math Platform offers a lot of capability you will find very useful. My objective for today is to provide a broad overview of the capabilities that Iota has, but I won't go into great detail. I will, however, do future videos where I will go into more depth on things like matrices, derivatives, graphs, even Taylor series. We have a Taylor series function that I think is really cool, and I'm excited to show you, but that will be in a future video. So without further delay, let's go into the system. Our website does have terms of service and a privacy policy. You can find those right here. And if you accept, click this button, and we're in. As this dialog box indicates, this is the beta release of Iota. And we have our email address right here, support@pikemathematics.org. We would really like to hear from you. If you're using the system and you have questions on how to operate it, or maybe you want to see some new capability added, or maybe you're using it and you think something's not quite working right, please email us. We would really like to hear from you. So send those emails. All right, so hit OK. And now we are in what we call the console. The console is where you can do a variety of calculations. So we'll ask the system to do something basic. What is 5 squared? I'll hit run. There you go. 5 squared is 25. But let's try something a little more interesting. Let's make a function, f of x. That's equal to x squared. So we define that function and then ask Iota, what's f of 5? And as before, 5 squared is 25. Okay, so now we've defined a function and used it. What else can we do with a function? Well, we could take its derivative. Iota does derivatives. It also does partial derivatives. But in this case, where we're just using a single variable, we'll just use the normal derivative. And to do that in Iota, you do a \d for derivative underscore x. So that's telling the system we want to do a derivative with respect to x. And the last thing you have to do is tell it what the function is, and that is f of x. All right. So what is the derivative with respect to x of x squared? It is 2x. All right. So those are functions. We can also work in matrices in Iota. So we're going to go ahead and define a matrix. Call it capital M. And in order to create a matrix in Iota, you have to use the square brackets. So we'll make a 2x2 symbolic matrix. It'll be, the first row will be AB, and the last row will be CD. There. All right, we've defined this matrix. For those that have taken linear algebra, oftentimes if you're given a matrix, they'll ask you, what's the inverse of that matrix? So let's go ahead and see if Iota can figure out the inverse here. Capital M, raised to the -1. We'll hit run. And there you go. That's the inverse of M. One of the capabilities that Iota has that I think is pretty unique and that we hope you use is if you click on a computation, highlight it like that, and then hit proof, it'll show you exactly how it came to its result. In this situation, what it did is it took 1 over the determinant and it multiplied that times every element in this matrix, which they call the adjugate or adjoint, to end up with the result right here. So we think this is a really critical piece of the whole system. This is so much more than just a calculator, and we hope you use this tool to kind of further your understanding of how these operations work. Close that. So that's the console. But we have other things. We have tables. Here we'll open a new table. Okay, and what do you do with tables? You put data into tables. Here, 2, 3, 5. Let's ask Iota to sum those entries. And to put an equation into a cell in a table, you have to start with an equal sign, SUM. What tell what cells to add up? A1 through A3. Okay. 10. 2 plus 3 plus 5 equals 10. That's right. Okay. Let's add some more here. How about instead of adding numbers, let's put some variables or symbols in here. But if you're going to put something other than a number, you have to put the equal sign in here and say A. How about that? Equals B into that cell equals C into that cell. And now we could, instead of adding them up like we did last time, we could subtract column A from column B. And to do that, we again start with the equal sign, reference the cell B1 minus A1. Oops, minus A1. Let's see what we get. There you go. A minus 2. Now to figure the result in these next two cells, instead of writing that same formula in there, you can just copy this and then paste it into the table. And there you go. B minus 3, C minus 5. Okay. So those are some things you can do in tables. I also, in another tab, I had created another table that I want to show you. It's right here. Okay. This table is populated with some vectors, and I want to make the point that uh, basically what Iota can do outside of a table, it can do inside of a table as well. And so it can recognize that these are vectors inside the table. And uh, I did not type these vectors in. What I did was I had a CSV file that already had them in there, and I was able to upload the CSV file by going to this. There's a settings button right here, and this window pops up. You go to upload data, math CSV file. So I uploaded that file, and it populated this table with what you see right now. So we have two columns of vectors. What could we do with those vectors? We could do dot products, for example. So let's try that. Put equals, and to do dot, well, first I need to reference the first vector, which would be A2. Okay. And to do dot products in Iota, you have to do backslash dot. There's the dot, and the second vector will be B2. There you go. That's the dot product between those two vectors. And again, I don't want to type that equation in again. I'm just going to copy it and paste it into these cells. And there you go. There's all the dot products. And so those are tables. What else do we have? Um, we have graphs. So go to new graphic. Okay. If you want to insert a graphic, you hit this insert function here, and we have a whole bunch of functions available to the user in this dropdown. Actually, when I hit the dropdown, you'll see the full list of it. I actually think for people watching the video, you're not actually going to see the drop-down video. There's kind of a quirk with the software that we're using to create the video that it doesn't actually show this drop-down menu, but I can assure you it's there. And if you don't believe me, you can go to the website and test it out yourself. But there's a whole bunch of different functions in this drop-down menu that you can use. And one example I'm going to use right now is called plot X. That's the one I tend to use to graph functions. So we hit plot X, and it's already populated with sine of 360x. And so you can hit test here, and it'll graph it. Now you may be wondering, why is it sine of 360x? That's because the system's currently in thinking in degrees, but you can change that. So I'll take the 360 out, and I go over here to sidebar math, and I can change it to start thinking in radians. All right, so now it's thinking in radians. Let's take that 360 out again. All right, test it again. There we go. There's the sine function. And I usually like to throw in a grid so you can see things, have a better understanding of where everything is. There's a grid. Actually, I'm going to go back and reapply this function. There we go. So there's the sine function laid on top of a grid. I also want to show you, let me open up a new graphic. This is a new feature we just created field. Okay, field. I won't go into a whole lot of detail here, but in future videos, when I talk about vector calculus, we'll talk about it. But this is to graph. This will actually graph vector fields. So let's just take a look at this one where it's negative yi plus xj. Let's see what it looks like. Oop, look, I made an error. I had this is telling me I forgot to tell the system that we're working in vectors. So again, I pull up this math bar, this math settings, and click classic vectors. So it starts to think in IJK unit vectors. Got that selected, and we'll test it again. There you go. So there's a vector field right there, negative yi plus xj. And these depictions are uh, hugely useful when you start working in vector fields. And that'll come up in a future video. We have a number of other graphics I'd like to show you that I've already previously graphed, and I'll quickly run through those. Here's a graph of e to the x, a graph of the natural log of x, and I threw in um, this dotted line here because that's basically the axis that you can reflect these two functions around, given that they're both inverses of each other. You can also graph polynomials in Iota. What's cool about graphing polynomials is when you do, if you want to find the roots, you look at where the polynomial crosses the x-axis, and those are your roots to that particular polynomial. Iota does really well with trigonometry. So again, here's the sine function. Here's the cosine function, here's the tangent function, and I inserted these dotted lines to represent the asymptotes for tangent. Here's x squared, x cubed. Iota also has an absolute value function, and it's graphed here. And this last one I just threw in because I thought it was a interesting looking polynomial. Again, look, if you want to find the roots, you look at where it crosses the x-axis. So it looks like for this particular polynomial, there's roots at 2, 1, 0, and -3. Okay, so those are graphs. We've talked about consoles, tables, and graphs. When I use Iota, I prefer to use what we call a paper. So let's pull one of those up. New paper. The paper is what really makes this a true platform where it brings all these different capabilities together. When you work in a paper, you can have that the console capability, the graphing capability, the table capabilities, all in one space. And I think that is a really good way to illustrate a variety of different problems in math and physics. So let's go ahead and try something here. I'm going to work with some vectors, and again, I'm going to make sure that I go to math and select classic vectors IJK. So the IJK unit vectors, and I always like to put the little hats on them. I think that makes it really clear that you're working with vectors. So let's do an example. I'm going to make a vector v underscore 1, and it's going to be equal to 5i plus 2j. Okay, my first vector, and then I'll make another one, v underscore 2, and that's going to be equal to negative I minus 3j. Okay, so now we have two vectors. What can you do with vectors? You can add them up. So let's go ahead and do that. And when I add them up, I'm going to, the result of that, I'm going to define that as a third vector, v3. So I'm going to say v3 is equal to v underscore 1 plus v underscore 2. There you go. So that's the sum of those two vectors. So you can add up vectors. You can also do dot products with vectors. So let's try that. We'll take v underscore 1, and then again in Iota to do dot products, you do backslash dot v underscore 2, and there you go. There's the dot product. Remember, the dot products are always scalars, and in this case, it's -11. One thing you can kind of demonstrate in Iota is that the dot product is commutative. So v1 dot v2 is the same as v2 dot v1. So let's show that. V underscore 2 dot v underscore 1. There you go. -11. They're both -11. You can also do cross products. Let's try that. v underscore 1. And to do a cross product in Iota, you do backslash CRO. Cross that with v underscore 2, and that is equal to negative 13k. And you can think about it, v1 and v2 were both in the xy plane, and so the cross product always creates another vector that's perpendicular to the first two. And since v1 and v2 are both in the xy plane, the result is a vector that is only has a k component here, this negative 13k. Okay. Now, unlike the dot product, the cross products aren't commutative. So let's see. Then they differ by the sign. So let's try the reverse. V underscore 2 cross V underscore 1 equals, there you go, 13k. So same magnitude, but different direction. All right, so we've done a few things with vectors. I want to do something else. We're going to introduce a graph. So I'm going to insert a graphic. All right. So this is kind of like console-like, and now we've inserted a graphic. Let's see here. I want to graph some vectors. The origin here is this is telling the system where to start the vector, and as you can see, it's not at 0, 0. So I'm going to change that. I want to make it 0, 0. So at the origin will be the origin. And I want to graph our first vector. Now, I don't want to type in, 5i, 2j. And this is where it makes it a really integrated platform. We've already defined what v sub 1 is. So I'm just going to take v underscore 1. And then we have a legend, so we can label the graphic. We'll label it v1. Let's see what it looks like. There we go. There's our vector. I hit the test button just to kind of see what it looks like, and it looks okay. Once I'm satisfied with it, I hit the append button, and that puts the actual script that the system's using into this box here and makes it a little more permanent. So I've graphed v1. Let's graph v2. But I want to change the color. We'll make it blue. Let me go ahead and just append it. There you go. So v1 and v2 listed here. And how about we put in their sum? That was v3. Okay, and we'll make it yellow. Let's see what it looks like. There we go. Now, it's a little difficult to read this because you don't really have a coordinate system to look at. So let's put in what we call a grid. And against a black backdrop, I always like to use white. And there we go. So now we have coordinate system and our 3 vectors. So that's a kind of a good example of integrating the kind of computations that we did with graphics. We can also insert a table. I'll go ahead and insert a table here. And just like with the graph, if I wanted to work with v1 or v2 or v3, I could do that here by just saying equals v underscore 1. There you go. And that's v1. Let's see, make this one v underscore 2. And we'll make this one v underscore 3. So I think that demonstrates how useful operating in the paper is, because you have all these capabilities together. So you can do your computations, your graphs, your tables. You can even insert an image if you had one that pertained to your work. You could insert that image right there. So I think that's most of what I wanted to talk about today. I hope you enjoyed this. I do want to make the point that anything you do in Iota, that work is yours, and you can save it by going up to this Iota tab, and you can download it. You can download all of your work, and the advantage then is if you come back to our website later, you can upload it and start right where you left off, or you can even print it and take it with you. So this is your data, and we want you to have it. I want to thank you again for taking the time to watch this video. Please keep an eye out for future videos. I think we're going to have some really interesting ones coming up very soon. And email us. Email us at the address support@pikemathematics.org. We really look forward to hearing from you, and we sincerely hope you'll find Iota useful. We think it's a great tool, and we think you will enjoy it as well. Thank you so much.